A standard Knurled knot does one thing. It lets you tighten it by hand, but this version has holes through its sides, allowing you to apply more torque and even lock it in one place. Today we'll be seeing why this small feature makes such a big difference and one common mistake engineers make when using it. Welcome back to the component file, where we break down one mechanical component at a time. Last episode was the wave washer. Today we are looking at the Knurled thumb nut with holes on the side. Hi everyone, if you're new here, my name is Jamal. I'm a mechanical design engineer with over 8 years of experience designing machines for automotive, aerospace, and industrial automation. If you are interested in machine design, SolidWorks, or preparing for CSWA or CSWP exam, you are in the right place. So what is it? It looks like a normal thumb nut, but it has two types of holes on the side. A plain hole, which is this one, for inserting a hex key to apply torque, and a threaded hole, which is this one, for screws that locks the nut in one position once it's tightened. One compact part with 3 functions at a time. Why it exists? This design solves 3 common problems that we face with normal thumb nuts. Finger tightening isn't always enough. Sometimes there is no room to grip the nut properly. And lastly, vibration loosens the hand tightened fasteners over time. How it works? So the way that this Knurled knot works is by inserting the hex key in the plain holes to increase the tightening torque, even in confined spaces. Then tighten the side screws to create a positive mechanical lock that resists vibration over time. Where to use it? So most of the time you will find this kind of thumb knot in precision fixture and jigs, recessed adjustment point in machines where you have no access, and machines exposed to vibration. Before moving into how to design these thumb nuts, a quick engineering tip. Before choosing a component like this one, ask yourself, do I really need the locking feature? That decision affects the cost, complexity, assembly time, and maintenance. That's exactly the kind of check covered in the machine design verification toolkit down below. Now, let's jump into how to design it. So the way we designed this thumb nut is to make it more realistic, but actually when it comes to designing a real engineering part that you would actually manufacture, because most of the time you would just purchase this from a ready catalog. So most of the time you wouldn't need to design these aesthetic looks that we have created into this thumb nut, mainly the thread and also the knurling on the side. But to actually make it visually look like a real one, we have created them and we'll take you over how to design them. So the steps that we have followed to create this thumb nut mainly are the extruded boss to create the main cylinder, and then we added a chamfer, and then we have created a helix spiral, which is this one, and then we created another one just to oppose it, and then we created a sweep cut on the side, just to start the knurling, and then we've created the second one, and then we've added a thread, which is this one in the middle, and then we added a chamfer, and then we started creating plans just for us to create the holes. So to show the plans, just click on this eye, and then here we go. That's the first plan, and then we've created the plain hole, which is this one here for the hex tool, and then we've created the second plan, orient by 45 degrees, and then we created a tapped hole. And then we have, of course, created a pattern of the holes on the sides. And then finally, we've created a circular pattern of the knurling. So let's hide these two, just for you to see how it looks like, or how the final result looks like. So let's actually jump into designing. So to design, just click on New, click on Part, and then click on OK. Alright, once you're here, click on the front face and then start sketching. So there are many ways of doing it. You can just choose the way that you like. I would also advise you to just go ahead and do it yourself and then click here to check how we have done it. So the external diameter is 44, the internal diameter is going to be 14. Is 14. Right, once you're done with that, just click OK and then go to extruded boss, and then let's make it 16. Alright, perfect. Now we got our first cylinder. Let's add in the chamfers. The chamfer is this one here. Let's just make it 1 millimeter. Alright, perfect. Got it. Now that we are done with that, you can just go ahead and add the thread in the middle. To add the thread, actually is only for visual show. You don't need to edit. You can just go ahead to hole wizard and just create the path hole directly by clicking here, and then by choosing the right element that you need, which is M16, is what we have on the catalog, and then click on position, and then you can choose the face, and then click on OK, and you will have your hole ready to be manufactured. But in our case, to make it more visually intriguing, you can just go ahead and create the thread itself. To create the thread, just go to select this edge right here, and then click on what you need, which is M16. You can either make it extrude or cut. So for us, let's use cut. Click on OK, and then you will have your cut clean and nice. Let's make it even longer, because for us it was the height that we have here is actually 16 millimeters. Now here's line, let's make it 16. And click on OK. And now that we are done with that, let's just go ahead and create our curve on our helix spiral. Let's select this face and let's convert this entity. Click on OK, and then you're ready to make your helix spiral. Let's click on height revolution, and then here let's make it 16 on the height. And for revolution, let's make it 0.5. Starting point, let's make it 0. Click on OK, and then you have your very first helix. Let's move on to the second one. Just click on this sketch right here, and then click on helix spiral. And then let's convert this entity again, and let's quit sketch. And here let's change direction, let's reverse direction. And then here let's change it to counterclockwise. Click on OK, and there you have it. So now that we are done with that, let's just go ahead and remove material so we can create our knurling. Let's click on this face and let's go to sketch, rectangle, and then let's just choose this point right here. A rectangle should be equal, and it should be 0.5. So we don't need our knurling to be really, let's just make it very as small as possible. And then let's remove material. And of course to do that, let's just select, let's go to sweep cut. Sweep cut profile is that one, and then path is that one, just click on OK. And then let's create the second one. Of course we'll be using the same sketch. Just click on it and then click on sweep cut and then click select path. And there you have it. So you will have something that looks like that. And then you can take these two lines here and then actually create a pattern. Create the pattern, just select this one here and let's make it 60. And we can see that our pattern is getting visible. It will take a little bit of time before it renders everything. Let's just give it time. Alright, now it's done. What we actually have to do before creating this knurling is actually creating our own so they won't interfere with the knurling once we create it. To do that, let's create plans. So our very first plan would be this one right here. Let's offset it by 22.5, which is the middle of 45. And let's create the second plan, and of course the second plan will be similar to the first one, except but of course it will be oriented by 45 degrees. Let's just select the face, and here let's make it 45. Alright, now that we have our second plan, let's click on OK. Let's select the first plan that we have created, and let's create a hole. Let's go to hole wizard. Let's go to fan hole, down hole, and then let's just select 6. The depth of the hole should be blind, and of course it should be only 8 millimeters deep. And let's just go here to actually make it in the middle. We just create a construction line, and then voila, there we have it. Click OK, and you have your very first hole. We forgot the chamfer on the top, and let's make it 7. Alright, perfect. We are done with the first one. Let's go to the second plan right now. Our second plan is this one here. Let's just select it, and let's go to hole wizard again. Of course, let's go to that hole, and let's make it an M6. Now M6 should be blind as well, and it should go all the way up 22.5. And of course here let's make it as well 7 mm. Click on OK, and let's go to the position. Of course, we have done to the first one. Just create a construction line. Let's make it here. Alright, perfect. We are done with that. Click OK, and there we have our top hole. Perfect. Now let's actually go to pattern. Let's make it a circular pattern. Let's select these two holes, this one, and the second one. So that we have them both direction. Let's select this line here, and of course we just make it 4 and not 60 as we have done to the knurling. Alright, so here we have all our holes together. Let's just hide the lines. We don't need to see them. Let's just hide the lines. We don't need to see them anymore. And of course, let's show our knurling up to this one. It will take a little bit of time before it shows up again. Let's just give time. Alright, voila, we got it now. So let's just hide these two lines and let's apply material. So most of the time we find this in many materials. So you can find them in bronze, or you can also find them in stainless steel. Sometimes also plain carbon steel with black oxide, of course. You can just choose the material that suits your application. Either you are applying it in chemical industry or just normal automotive. So it makes such a big difference. So now let's move to the common mistakes that most of engineers make. The biggest mistake that engineers make is actually using the nut without installing the set of screws. If you don't use the lock-in features, you are paying for a capability that you are not taking an advantage of. So if you don't need to use the set of screws, just go for the normal thumb nut. So this isn't just knurled nut, it's a hand-tightened fastener, a wrench-assisted fastener, and a lock-in fastener, all in one compact component. In the next episode, we'll be exploring the retaining ring. If you are enjoying this component file, subscribe for more real-world machine design breakdowns. And if you want to make better component selection decision, download the machine design verification toolkits using the link below. Again, thanks for watching and see you in the next one.